Okay, everybody, welcome back to episode 6 of Beltmatic. Next number up in the series is 701, which I believe to be a prime. So I think the most easy way to do 701 is just to do 100 times that with 7 and add 1 at least. But before we do that, let's upgrade this divider and subtractor thing, and let's see if we can't find a proper place to make the 700. I think a nice way to make 700 is just to take 5, 5, 4, and 7 into one of these quadruple multipliers we have. So let's do that here. And let's see, where did we have those 5s, 4s, and 7s? I believe they are over here. And here's also a neat one we can add afterwards. Let's just find a nice addition array over here. For example, this thing. Build that over here. And now we just do that. Put the belt in like this. And extract some ones from over here, bring them over here like this and into here, and this should output 701 once we put all the parts into here. So we want 5s, 7s, and 4. First we utilize 5 and 5 to make 25. Then we take 25 multiplied by 4 to make 100, and 7 times 100 becomes 700. That, and then we add 1 to that, and that should be 701. Where is the delivery unit? We need to deliver them all the way over here. Let's just put it next to this line over here, which delivers 636, and drag it all the way down here like there. And there is a neat little place to deliver. That's 3 over there. Okay, that's 701 made. We aren't really making loads of the numbers yet, but it will at least be something for now. Of course, if we really want to, you can just make a secondary factory like this, just next to here, and have twice the output. I am decently confident that this line should fill up after a while, or did we copy the tiny one? No, it looks like it's the right size. It doesn't matter too much. We will it will fill up in time. I think we just need to make sure that all the 700s are getting all the way down here. We aren't properly filling out all the way over here. Actually, we could even, I don't know if it makes sense to put several streams of numbers into here, but maybe that's actually a trick here. Put more numbers into the machine, get more output. Yeah, we have more output now. Looks like that really helped. Because this line is full, meaning that we should output a full line over here just after this machine catches up. Okay, we are also having to be on the lookout for some more numbers. We are producing this, and this number. We aren't producing enough 36s. Maybe we should work a little bit on that. And also there is a 3379 we need to address at some point. Let's first do the easy thing, make more 36s. The 36s are currently sharing up a delivery site together with these 18s, and they have priority, or at least they should have priority. Now they have priority. We no longer need the 18s, right? Yeah, we don't need the 18s, so the 18s don't need to clog up that system. Yeah, there's lots of numbers here. We don't really need anymore. Ooh, another one finished. That's increased extractor levels, great. And now we also need 1688. 688, that's probably a fun number to multiply, because 1600 is like 40 times 40, and 88 is also 4 based, so I think we should be able to get this number by just multiplying lots of numbers. Let's try to make that happen. Let's see if I put one of these here. So let's see. Dividing this number by 8, then we get 211. So 211, that might be a stupid number. That might be a prime, because it's not divisible by 7 because 21. It's not divisible by 3 because if you add the numbers together they are like 4. So maybe it's not a good number for that, but maybe we can just maybe we just do one of these to make 210. Then we add 1 and multiply that by 4. That's a neat way to do it. That should be decently easy. It's like 7, 3, and 10. So like 3, 7, 2, and 5. Over here, bonk, 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 bonk. Okay, so your job is to produce 210. And then we add 1, and then we multiply that by 8. 8 is over here and over there, and there's a 1 over there, so that should be decently easy. We need to add 1 like this, probably. We missed that input line. Okay, actually we missed the entire input line. Let's see, can we do this even better? Rotate, rotate, and let's see, do it like this. That way I don't have to realign as much. And these 2 10s, you're coming over here. And then we need to add just a simple multiplication line, which we can take from over here. This one is really small. We probably want to have a larger one. So let's see, we do this, and then we copy just this part and add it over here. Okay. Take this belt over here, and then find this 8. Ooh, thank you. Another thing is done, and this 8 comes in over there. This should be 1688, and then it's just to take all the numbers over here and find a free space to deliver them into. So let's see, we are also done with multiplication levels. Awesome, that means we no longer need 66, I think. Yeah, which means that we can find where we are delivering 66, and we can repurpose this belt. Okay, we no longer need you guys to be that input. So this belt is free, meaning that this belt over here can come down here and deliver up to this belt. Okay, let's do it like that. And these 44s probably aren't needed anymore either. Yeah, we also are done with 44. let's do some cleanup here. We don't need 44. We don't need 73 anymore. They are done. That's these guys. I do like the clock delivering though, but yeah. The clock is done. 44 is done. 3s are probably done. And if not, they are probably easily replaced. Okay. Let's just clean up that here. And clean up this thing as well. Clean up this 3. And this entire 44 factory. And this 66 factory. And this 73 factory. 52 factory is probably also no longer needed. I hope. Yeah, we basically only need 36 of numbers under 100. So yeah, we can freely demolish a lot of things, except that we kind of want to have the machines around so we can copy them. And this is just a very complicated way of making 11. No, we're making loads of 11s. Ah, right. The perils of youth. Okay, so wait. Oh yeah, this is a number we are trying to make. I was like, wait, we're making a number that's too large. But like, no, we're supposed to make that number. That's precisely what the doctor ordered. Okay, we have 2 free lines to deliver to here. Let's find some number to actually create, and these numbers are starting to pop in. Lovely. Okay, so we can create either 3379 or 4750. I think 4750 is the most appealing one, since we don't really need subtraction and division, but multiplication speed actually counts for something. So let's just find out what we need to multiply by 50 to get 4,750. So 50 times 80 is 4,000, and 50 times 15 is 750. So 50 times 95 should be 4,750. So we need to make 50. We need to make 95. Ringing my brain. So that's 19 times 5 times 5 times 10. 19 times 5. Can we? Yeah, we can't extract 19 yet. We can extract up to. We can extract up to 12. So we need to find a different way. 19 is a prime, so we can't just multiply together to get that. Can we get 95 another way? I don't think we can. It's like, we need to make 19. That's not the worst thing. We'll just add 11 and 8, for example. Yeah. Okay. So let's make you over here. But we also need an addition setup, like this thing. Swoop. And we need to make, let's see, this is the input side. Do it like that. And we can demolish this part. Okay, so extraction, we are making 19. It might be a better way to make this happen than to create 19, but I just can't imagine it just right now. So it's what we're doing here. So that's 19 times 5. That should be 95, and then we need, what did I say, 50. So we need 250, and we need to get 250 without multiplying 3 numbers together. I don't think that's possible unless we have a 10, but we basically need to do something like this again to make a 10. 4 and 6, sure. When we are already doing additions, why not do double additions? Okay, so we have a 6 here. You will be this number. Copy that. Copy this 4. Scoop. And this should be 10. And then we take another line out from here, and that should make the 10s into 50, which should make 95 times 50 into 4,750. If my math isn't completely wrong, which it every now and then is. Let's pay attention to this before we are delivering. And ooh, belt speed upgrade, thank you. And now we just need to make more high numbers. Okay. Let's see. Double check. 50, 4750. Yes, it's correct. Okay. We are bringing that to over here. So let's just bring it over here. Get it a little bit down, right? And we need to hit like over here, so let's just do this and then do it back again and bring it over up over this thing, even though we don't need it anymore, and bring it into that thing and demolish this part. Okay, now we are delivering 4750s. Nice. And let's see, we have some time for some more numbers. This one has waited the longest, but I'm more eager to work on belt speed. So let's see, 4, 5, 6, 6. Basically it's basically a few fewer times 50 and then added 16. If that makes sense. The numbers are starting to become slightly issueful for me. So here we have 95 times 50 to be 750. And basically I want to make 250 less. So 90 times 50, yeah, of course 9 times 5 is 4005. So 90 times 50 times a plus 16. That should be decently easy. Okay. Bring it over here. Okay, how can we do that easily? So 12s are interesting. 12s times 5 is 60. And where do we want to go with that? It's like, yeah, so 12 times 5 is 60, but 12 times 15 is 180. And 180 is kind of like 90, except it's 90 times 2. Does that help us? Because then we can take 180 minus or times 25 instead. I don't think it helps us enough. Maybe I should bring out a calculator, but I think a little bit of the fun in the challenge is not to use calculators and try to find a proper way to do this ourselves. So 15 times 6 is also 90. You know what I think? I think we just need to make one of these machines that allow us to combine even more numbers into high numbers, because these numbers, they're just going to get higher and higher and higher and higher. So I am going to accept that we are adding on an entire additional layer here. How many layers are we doing? Are we doing like I think this is excessive. I think we don't need that much addition. I think we need like this. This is like a 2 to 1. Oh, the music has stopped. Let's restart it. Yeah, and let's regret that. We need to add the entire thing, I think. Maybe we do add this part once more instead. So okay, bring it up here like that. So this makes let's demolish this part here. No. You have one thing coming in here. I just need to orient it so that we can have everything coming in from the same place. So something comes in here, that goes the way around and gets up there. One thing comes in here, one comes in there, one comes in there, and maybe we add a similar thing like this to the other side. I think we do, so we can multiply 6 numbers together instead of just 4, because 4 is not enough anymore. Okay, so you take your inputs from here, you take your inputs there, and you take your inputs over here. So now we're bringing in 6 things. And we don't need to do the entire math at the same time, we only need to just know what kind of parts we want. So let's bring back this thing. We need to make 4,500, which is what we call 90 times 90 times 50. So that's of course going to be 9, and then we need to make 10. So here is a 5 and a 2. And we can also use the 5 and the 2 to make the second 10, and the 5 to make the 50. So yeah, this should be it. Maybe we can place it somewhere where the 5s and the 2s and the 9s are closer. So for example, there's 5 to 9 over here. Yeah, that's better. So we are, let's see, we are cutting out this thing like this and bringing it over here. Okay, that's 5 is going to have a field day. This 9 is only going to deliver once. That 2 is going to deliver there and there. And this 5 here is going to be in here 3 times. And this should produce something that's only 16 of. And we can use that to just add 16. Is there we can't make 16 just yet, so let's copy this thing. And is there an 8 nearby? No 8s? There's an 8. Okay, so we do it like that, and we just need to make a small multiplication array. We could use the 4s as well. That one is bad. Let's take this one instead. It's not that tight, but it's easy to understand. Okay. So here is an 8, and here is an 2. Go over here and put into you. And we use this over here, there, and we want to put you into that thing. And these outputs we'll put into this thing. And now we can clearly see that, I was gonna say the factory is wrong, but no, it puts the input from 1 out of 5, that was wrong. Okay, let's just see. How is this doing? You are supposed to produce 125 now. There's also something wrong with the output over here, so we need to put these 18s into stuff like this. And yeah, that's 4,500, and here are 16s, and when we add those together, that should be correct. Okay, cool. Remove that, and once again, we need to find some way to get all the way over to where we are supposed to deliver. Now, here is one of the things that I wouldn't mind if they copied off Shapez, is that some easy way to deliver long distance numbers would be nice. Okay, other than that, we now have a new order, 817, and if we do that, we are gonna Exponentiator. Hello there. That sounds like the a new machine to play around with, and oh, this is gonna be so good. This is probably going to open up the opportunity to make really crazy numbers without having to worry too much about finding lots and lots of numbers. Yeah, we need to be making that thing ASAP. Okay, how can we do that? So there's like 817. Every time I see a number that's ending with 7, I'm just automatically thinking it's a prime. So let's check, is this a prime? It can't be divided by 3, so and 5 and 10 and 2, so a lot of the usual suspects are gone. If we subtract 700 and 7, we get 111 left. That's not divisible by 7, so it's not a 7-based one either, and probably not 11-based. Yeah, because that would be like 888, and you can't add 11s to get 888. I'm not that good at dividing with 13 and dividing by 17 and stuff, but yeah, this looks primey to me. So we need to find a different way to make it, and I'm just thinking we do 800 plus 17. That looks like a decently easy way to make 817. So let's put one of these and figure out a way to make 800. Shouldn't be that hard. It's like 8455, which we have 84 and 5 over here. 554. 84. I don't want I don't want to take up so much space. Okay, let's just build it over here where we know that the resources are. Okay, so what did it say? 4 8 4 8 and double 5s. Scoop. You guys come over here and you go into there. So 25 times 32 should be 800. If we can hit. And then we needed to add. Then we needed to add. Add what? We needed to add. Oh, where is it? It's over there. We needed to add 17, which shouldn't be the biggest of asks. 9 and another 8. Yeah, let's do it like that. So we need to copy this thing twice, or we just only need to copy it once, but we need to add it twice. So we can do this and this, and thinking to bring these guys all the way over there, and these guys come over here, and all the way over there, and we will utilize that thing as an input and this thing as an input. So we can take 9 in here, and we take another line of 8 in here, and that should be 8, 17. Let's just look that it becomes correct before we leave this place, but I think it's pretty apparent that this is 808, and 808 plus 9 should be 817. So we need to just find a way to put that into the central processing unit. Bring it down here, and some of these lines should be redistributable. For example, this 29 line is no longer needed. Your services are appreciated, but you are now rendered obsolete. But you are not obsolete, but we can't reuse you, so that should be it. And come on, 817. No, you're doing the wrong way. Okay, there we are. And that should be it for today. I am very excited to see what happens when we unlock the exponentiator in the next episode, because it sounds pretty fun, both in name, and I'm excited to see what kind of uses we can get out of this thing. And for now, I hope that you enjoy this playthrough of Beltmatic, and I will see you guys in the next one. Take care!